So for number 4, a proton charge Q1 equals 1.6 times 10 to the negative 19 coulomb is at location R1, which is 5 times 10 to the negative 6, 2 times 10 to the negative 6, and 0 meters, and an electron charge Q2 equals negative 1.6 times 10 to the 19th coulomb is located at R2, 3 times 10 to the negative 6, and then 9 times 10 to the negative 6, and 0 meters. The proton and electron are in outer space, far from any other objects. So this is the diagram, and the first question asked, determine the relative position vector that points from the proton to the electron. Your answer should be a vector and in SI units. So it is relative position vector from the proton to the electron, so we have to subtract the position of electron from proton, because the relative position vector is final position minus initial position. So we have R vector equals 2 minus R1 equals so we know that so this is the answer for number 1. And number 2, what is the unit vector that points from the proton to the electron? Your answer should be in a vector form. So to find the unit vector, we have to know the magnitude first, which is and unit vector is when you divide the position vector by the magnitude of the position vector, which is this is R. Okay, so for number 3, we have determine the magnitude of the electric force on the electron due to the proton. Your answer should be in SI units. So F electric equals 4 pi to 0 over 1 times Q1 times Q2 over R square. So which is 9 times 10 to the 9.6 times 10 to 19 given coulombs, and then position vector times square. So this equals, well, actually there should be negative in front of it, but since it is the magnitude, it is absolute values, so we discard this. So the answer should be 4.3478 to the negative 18. Okay, so for number D, determine the electric force on the electron due to the proton. Your answer should be in a vector form. So to find this, we have to use the magnitude of the force times unit vector, which is times the unit vector, which is and this equals this. Okay, so next, the last question, determine the electric force on the proton due to the electron. Your answer should be a vector and in SI units. So to determine it, you have to find the position vector from R2 to R1. So we have to subtract R2 from R1, which is substitute that from, and this equals this one. So hence F equals 10 to the negative 18th part 1 and 0.